All right, let's dive right into this explainer. Today, we're exploring a fascinating 1970s tech fable where sheer, unadulterated chaos actually solved a massively complex programming problem. You know, when we think about coding today, it's all sleek laptops, instant cloud computing, perfectly secure backups, right? It's the ultimate domain of order and control. But we're going to look at a true story recorded by Octavio Baez Hidalgo from the early days of computing that literally turns that entire assumption upside down. It's just a brilliant reminder of how wonderfully weird tech history really is.
So, I gotta ask, has a total disaster ever accidentally fixed your biggest problem? We've all had those moments of sheer panic, right? Spilling coffee on a keyboard, accidentally trashing a crucial file. Usually the outcome is exactly as bad as you'd expect. But what happens when you take highly rigid, unforgiving computer code and subject it to a literal, chaotic physical disaster? Because back when code was physical, disaster meant something else entirely. Keep that in mind as we travel back to the early 70s to see how a total catastrophe actually paved the way for a miracle solution.
Okay, Section 1, the ANFACT project. Let's get into it. Let's set the scene. Between 1973 and 1974, at a major center's mathematics department, programmer Raisa Cepero Bonilla and our source's author were tackling a massive undertaking. Back then, you didn't just casually write an app, you went on mathematical crusades. To really get the stakes, we have to look at their project, ANFACT, or Factorial Analysis by Correspondence. Now, you don't need a PhD in statistics to appreciate the gravity here. This was a highly sophisticated statistical analysis method. Honestly, it involves such intense mathematical heavy lifting that our source notes it has limited utilization even today. They were pushing the absolute boundaries of their hardware, basically doing heavy-duty data science half a century ago.
And this brilliantly captures the crazy paradox of that era. On one hand, you had the hardware. They were running this on advanced French Iris 10 computers, these massive cutting-edge mainframes. But on the other hand, how did you actually talk to this magnificent machine? Paper. Archaic, flimsy, easily destroyed paper punch cards. You're basically doing space-age math using a medium that's one step removed from a player piano. The logic was completely digital, but the reality was intensely, stubbornly physical.
Moving on to Section 2, the punch card era. To really feel the impending anxiety of this story, you have to grasp the physical weight of this code. 2,000! That is the number of physical cards this single ANFACT program required. Each card was essentially one line of code, meticulously punched with tiny rectangular holes. The whole program filled two massive, heavy cardboard boxes, each holding a staggering 1,000 cards. Imagine your current biggest work project, but instead of a folder on your desktop, it's sitting in two heavy boxes right in front of you. Drop a laptop today, maybe you crack the screen. Drop a box of punch cards, well, the physical order of those cards is the literal logic of your program.
And the kicker? They were already struggling. This was not a pristine, perfectly functioning program. The team had been wrestling with this 2,000-card behemoth for a while. They had applied previously programmed fixes, physically swapping out bad cards for new ones, but it was still yielding bad results. It was buggy. And debugging back then didn't mean running a diagnostic tool. It meant reading a massive physical printout, finding the logical error, hunting down which exact paper card out of 2,000 contained the flaw, pulling it out with your fingers, punching a new one, slotting it back in, and running the entire heavy stack through the machine all over again. Absolutely tedious work.
Which brings us to Section 3, the chaotic commute. And man, this is where things go off the rails.
So to get this code across town to the Iris 10 mainframe, they had a driver. Let me read you this quote directly from Octavio Baez Hidalgo's account. He says, as he had been an ambulance driver, he was given to run like the wind. I mean, I love that detail. It sets the perfect stage for disaster. You've got this highly fragile, incredibly tedious paper puzzle, and you're handing it over to a guy who treats a standard commuter sedan like a speeding ambulance. He's fast, he's impatient, and he completely expects everyone to move at his speed.
Our narrator is holding these two precious boxes of mathematical logic. He walks up to the car, opens the door, and before he's even completely inside the vehicle, our former ambulance driver just hits the gas. He starts moving. Gravity and momentum take over. The two boxes slip from his grip, tumble to the floor, roll out, and all 2,000 perfectly ordered, meticulously crafted punch cards scatter wildly across the street. The wind catches them, the dirt hits them.
Months of sophisticated statistical analysis instantly transformed into a chaotic pile of street litter. Just unimaginable panic.
Can you mentally walk through the sheer agony of this recovery process with me? Step 1. They stop the car immediately, right in the middle of this cloud of panic. Step 2. They have to crawl around on the streets, scraping these cards off the ground one by one. And remember, these have to be absolutely pristine to pass through the computer's optical reader. Step 3. With zero time or space to sort anything on the asphalt, they just grab handfuls of this highly sophisticated mathematical code and stuff them back into the boxes in completely random order. Step 4. Heartbroken and probably terrified of what they've just done to Raisa Cepero Bonilla's project, they finally leave for the calculation center. The physical logic of the program is completely destroyed.
Let's jump to Section 4, the miracle compilation.
Because the story definitely doesn't end on the side of the road. They had a job to do and a machine time slot waiting. Let's look at their timeline at the calculation center. They arrive with these wildly mixed up boxes. Now, how on earth do you fix 2,000 scrambled cards? You need a reference. But here's the absolute worst part. They didn't have a printout of the current version of the code. They only had an old, outdated previous list of the program. So they sit down and begin the agonizing, painstaking process of sorting all 2,000 cards one by one. They're essentially flying blind, guessing how their newest fixes fit into an archaic, outdated map of their code. Finally, they rebuild the deck. They hand the boxes over to the operator. The massive Iris 10 whirs to life. Optical sensors reading the cards. The team is waiting, fully expecting the machine to just spit out a massive stack of error codes. I mean, the program was buggy before they dropped it, and they just reconstructed it using an outdated list. But instead came an absolute burst of surprise. The program compiled and executed to 1,000 wonders. The bugs were just gone. This random disorder somehow birthed a perfect new order. By dropping the cards in the dirt and manually resorting them with an imperfect reference, they accidentally assembled a flawless string of code. Unbelievable, right? Which really leaves us with this incredible, almost philosophical question to close on. Which missing or reordered card actually perfected the program? Like, was a buggy card literally blown away by the wind on the street, leaving only the good code behind? Or when they were desperately resorting with that old list, did they accidentally place a card in a brand new, unintended position that serendipitously fixed the logic loop? We'll never know. As Octavio Baez Hidalgo wrote, he never saw or experienced anything like it ever again. It's just a beautiful reminder that while we strive for perfect, rigid control in our work, sometimes a little bit of sheer, unpredictable chaos is exactly the catalyst we need. Thanks for joining me on this explainer, and I hope this inspires you to look at your own happy accidents in a whole new light.